Hello and welcome to Alucard Vehicle Rentals. So I'll quickly run through each feature and then I'll touch on the major parts of the code that I worked on. So let's run the app. So initially there's a user called John Doe with password bar. This is provided by default. And when we sign in, we can see that John Doe is an admin. This was something that we considered, but there isn't really an admin user. We can register a new user, and I give it a username Bradley, password Watkins, and give it role 1. Okay. So now at any point in the application, we can hit Q to end the application. And if I run again, I can log in with my new user. There we go, username Bradley. We also have the option to, instead of explicitly entering our username and password, we can enter these as program arguments using the tags -u and -p. And now when I run the application, it will automatically log me in as Bradley. So next we have, well, let's just run through each page. We can list vehicles, and we can do that by all vehicles, or we can list them by pickup location. And we've got 3 pickup locations by default. So if I pick value 1, which is Cardiff, we see that Cardiff has 4 vehicles, Nissan, Lamborghini, Volkswagen, and a Ford. We can go back to the homepage. We can make a booking. So let's list all current bookings. So we can see we have 1 maintenance booking that's in progress, 1 booking that's in progress, and 1 rental that's in progress. And we can create one of these ourselves. So we'll create a couple of these. Let's put it for Newport. We want to pick up a Mercedes, and we're going to drop it off at Newport again when we finish. So this will be a booking. So booking will be the route to getting a rental. So we'll book the car first. And if I enter my name, my address, this can be in any format, and then card for payment details. And we can see that new booking here. So we've got type booking, vehicle Mercedes, location for drop-off is in Newport. So at that point, we can actually, well, let's just show cancelling a booking. No, if I cancel that booking that we just created, we can now see that the status is cancelled here. Now if I make another one, so this time let's say Swansea, we're going to pick up a Subaru, which is available at the Swansea branch, and drop it off in Cardiff, and this will be a booking. Okay, so now let's pick up our rental. Actually, tell you what, let's amend the booking vehicle. So the one we just created was number 1. We can see the Subaru, and we want to amend the vehicle for this. Now it will only let you swap to a vehicle that is available at the pickup branch. So you can see here the only other available vehicle is a Ford. So if I can swap to that, and if I list all bookings now, we'll see that our booking now has the Ford Model T. I can suspend that booking. So this will prevent me from picking up the vehicle and continuing with my rental. And I can reinstate the booking, which will actually allow me to continue with my rental. Finally, on this page, we have update username on a booking. So let's say I entered some erroneous data. Rather than Brad, I want to be Yestin. And now when I list all vehicles, we see username Yestin on this. Now, if we dig down into the rentals page, we can record a pickup, which will start our rental. And at this point, we can view all active rentals. You can see we have two. This one we just began and one that was already in place. We can cancel a rental. So this will show all the bookings, where you'll see the rentals are available here for cancel. So if I cancel this one, it will say your rental is now cancelled. A team member will pick up the vehicle at the following address, and this is the address entered at the time of the booking. We can record a drop-off, which will complete our rental. And if I record one more pickup, just to create another rental, view all active rentals again, so we see just one now. We can request a collection, which will also complete our rental. Collection's been requested. A team member will be around to pick up the vehicle at the following address, and again, this is the address entered at the time of the booking. I go back to the home page. Now we can actually create a vehicle. So if I want to create this at Newport. Oh, oops. I want to create a van. Vehicle make. Could be a Merc. Vehicle model. Just be van. Reg 1, 2, 3, 4, 5. Who cares? Now, if I list all vehicles, we can list either all vehicles or at specific location. And now if we pick Newport, we see the Mercedes van is right here. Now, whenever you list a vehicle, it will always show its availability. So I think if we have some in progress rentals, oh yeah, you'll see here, the Vauxhall Corsa is no longer available because we have a maintenance or repair in place, I believe. We can then go back. We can search for vehicles rather than just listing vehicles, and we can do that by ID. So this is the database ID. We can search by model. If I go Corsa, it will show that it's not available. We can go by make. I think we have a couple of Mercedes in there now. Yeah. And by type. So if I go car, oh, whoops. Search by type. It was a number entry. So I search by car. We'll see all the cars we've got and their availability. Also, we can search by pickup location with all the same things above, we also have availability here. So if I search by available, we should see all the cars that come back are true. And if I do the opposite and search by unavailable, we should just see the one Corsa. So if we come back and look at the locations page, oh, one thing I didn't show actually was on the vehicles page, we can sell a vehicle. So this would be an admin operation if those roles were in place. So they're expected to know the ID at this point. If I enter ID, well, let's find out what the ID of that Corsa was. The ID of the Corsa is 1. This should fail because it's currently booked, so it cannot be sold. So if I select a different vehicle, let's say vehicle ID 5, we want to sell our Lamborghini. There we go. Now, when we list all vehicles, we should no longer see the Lamborghini with ID 5 in this list. It no longer exists from an application standpoint. What other operations do we have here? Okay, so we can list all pickup locations. We can list all drop-off locations. So these distinct pickup locations hold vehicles, whereas drop-off locations are locations you can end a booking at, but don't necessarily contain any vehicles. And we can search for pickup locations. This is less useful. What it basically allows us to check is, does this exist? But it doesn't go any further than that. So I believe that was all functionality of the app. Now, if we drill down to the code, the key points I worked on, working up to our MVP, were login and register with the first parts. So in order to do that, you can see our layered architecture here. We've got seams, which handle our user interaction. And here we've got a user login seam. So this runs when you first run main. You can see that here. And it will check. First, do we have username and password from arguments? So that's our program arguments -u and -p. If we check this, it goes through, try get username from args. We've got this find arg method that loops through our program arguments. And if it finds the key, then it returns the next value. If that doesn't exist, it'll throw an invalid args exception. We created a couple of explicit exceptions so that we can catch these. If they don't exist, we will get it from the user input, and then we'll attempt to log in through our service layer. So if I drill down, services, so application user service, we've got log in, which takes the username and password. First thing it does is hashes the password. We don't store any plain text passwords in the database. So it'll hash the text of this password using a salt. Now this isn't a super secure hashing by any means, but for an academic purpose, we see we add the salt. This is our salt. We use SHA-512, and we encode the string into our hash. We then find if any users exist with that username and password down in our repository layer. This populates this model, sends it back to the service layer. If this is null, we throw no such user. We log out all existing users. One thing we were playing with the idea of is keeping a user logged in. We didn't go with that, but this is here anyway. We log in our current user, update it in the database so that it has that logged in tag, and sends this back to our seam layer. This keeps track of our logged in user, so at any point in the application, if we were to go down the route of roles, this could be checked and the role could be looked at to see if they're authorized for certain operations. I then worked on register, which has its own seam. So this, again, we were playing with the idea of roles. So if the user's not logged in, or the logged in user is not an admin, we were going to throw registration failed exception. This is the only place we use this idea, but I think it's good to show it. So we take username and password, we give them the options of their roles through the service layer, which just digs down into the repository layer, pulls it from the database, pulls them back, gives them the options via index, and then we call service.register. And similar to login, we do some error handling here for our business logic. We check if a user with that username already exists, and we fail at that point. If they don't exist, we start to build up this application user. We hash the plain text password for saving in the database, and then we save and return this newly created user. After register and login, I worked on this. If I go back to main, we wanted to make sure that when the application is run, all of the tables and the dummy data are populated without the user having to go in and create these explicitly in the database. So we've got this migration service. This doesn't need a user seam because there's no user interaction here. So we dig straight down into the service layer. And at this point, I realized it would be helpful to have some factories. I don't know if this is explicitly correct for the factory pattern, but basically we've got these factories that deal with building up and creating our services and our repositories. So we can see this one builds our database connection through this dbutils.connect. This should have gone in an environment variable file somewhere, but it's here for now. It pulls our DB properties and creates this connection string. If the connection already exists, it just gives us that connection back. So this is a singleton operation. We can... I'm lost now. If I go back to main. Okay, we've got this migration.migrate. So this is our service, which will handle digging down and creating all of these tables in the correct order. So first migrates the user, and this, I don't know if there's much need to show all of them, but if I show, for example, user migrate and booking migrate, first we create the tables. So we're digging down now into our repository layer. We create the tables that we need. So we've got role table, we've got user table. Role table has to come first because the user table relies on it. And when we migrate the booking, similar thing, we make sure booking type and booking status exist before the booking table is created. And then we populate our data in the same way. So we've got booking type data, booking status data. There are no dummy bookings created at the time of run. That's left to the user. But if we look at migrate application user data, we create this initial user, so John Doe, and then the hashed version of bar. At any point, it might throw a migration failed, or in dbutils, we've also got connection to db failed exception. So if I were to fudge up this connection string, we get a useful error saying connection to database failed, ensure you have database AluCard and the connection string is valid, and it shows you the current connection string. So you can see at a glance if something's gone wrong at this stage. All of these have 100% test coverage. So if I show some of the tests, what we didn't, or what I didn't test, was the repository layer. But if I show the, for example, application user service test, we mock out our repository and our security utilities. So this is what handles hashing. We inject these via dependency injection, and then we're checking, does everything get called in the order we expect? Are we getting back the things we expect? And all that good stuff. The repository layer, I wish I had spent the time to try and understand mocking out the connection and the prepared statements. So this was one that I created towards the end, but we didn't really have time to go through and do this for the rest of the repositories. We can see that all of our tests do pass. So if I run these quickly. But at the time, although I was going test-driven, so I did test-driven for most of this week up until the final crunch. But yeah, the repository layer definitely took a backseat, and I think it would have been very helpful to test out the SQL queries that we're going through and make sure everything was exactly as it should have been. But everything else, we've got application user service, which tests login and register. We've got migration service tests that checks that all of the repository layer is called in the correct order. So for example, here we force migrate location, which does the table, to fail, and then we verify that migrate location data never gets called, because by the time it gets to here, it's already failed via this SQL exception. The other key part I worked on was the booking service. I'll run through this relatively quickly, but we've got here a seam for user booking. So this make booking. So what it does, it's got access to our booking service, location service, and vehicle service, because these are the three services that deal with the data or the business logic of everything needed for a booking. So we get all our pickup locations and we get them to select. So that's that flow we saw through running the actual application when I create a booking. So 3, create a booking. And these options are exactly what you're seeing here. So if I select 0, then we come down to vehicle options at that location. So for this, I had to create get all vehicles at pickup location, get XYZ, all of which, if you dig down, we come through our service layer and we see here all the SQL and building up of this. The models needed to build a booking. What I did create right at the start, probably one of the first things I worked on, were these, where did I put them? If I go to user booking, these input and output objects, which get injected through dependency injection to all of our seams. We could mock these for testing. So what we have next line, which does exactly what we expect it to do using a scanner, but through mocking we can force certain inputs to allow the flow to continue without needing to mock out system.in. I also created this next line from list where we could constrain the options the user is allowed to enter, and we throw input mismatch exception if they enter something that doesn't exist here. And we see this used extensively throughout the application. We build up location options here, for example, based on what locations are available, and they can select from this list. And we see if you select something that doesn't exist, for example, if I've turned to 40, we see invalid choice. Similarly for the output, there's less going on in this object, but we could mock out, and if desired, we could check that certain strings were being printed to the console via this message. Before we realized we were going to use Mockito, I actually built some fake versions of these explicitly, where we extend them and we have the overrides of next int, next line, and we could force these to throw exceptions, throw on next int by setting this to true, or we could count how many times the method was called. We could tell it exactly what to call them, what to return and in what order. So this was really cool, but we did go with the Mockito in the end. The other thing in input that was very helpful was this throw if safe word. So we define this end program safe word, which is Q, which is what you see in every input throughout any part of the application. So if I go register, enter Brad, if now I hit Q, it will kill the application. And this is because it throws an end program exception, which in main we catch, and we gracefully end the application at this point. I think there were other aspects of the application I worked on, of course. Or maybe final point will be this, the deleted operation. So initially we hadn't had a connection between the vehicle and pickup when it was created, this operation. So it was quite a heavy change to make it so we weren't actually deleting from the database. We were setting the deleted column to true. And you'll see in all of the, if I go to repositories, vehicle repository, you'll see that we exclude all true deleted, and in all of our values here, when we're trying to get a vehicle, we make sure it's as if that deleted vehicle is non-existent, basically, and that allows us to retain our booking historical data, because we were running into problems where when we deleted a vehicle, it would then need to delete the join table record that referenced the vehicle, which would then need to delete the booking, and we'd lose our historical data. But yeah, I think that is all I need to cover here. We can see the layered architecture. I think I've run over the cool stuff like this args utils, registering with and login with hashing on the password, and the booking via this seam with our injected dependencies. We've also got a factory for this user booking, which again handles building all of these services via their own factories, injecting these into a singleton user booking, and then returning that booking, rather than creating all of these explicitly in our main method or through our user interface, for example. Yeah, I think that covers everything off. Thank you for listening.